Today, we are diving deep into the fascinating world of transformers, quantization, and neural networks. These are the building blocks of many cutting-edge technologies we see today, from natural language processing to computer vision. Let's start with neural networks, the foundation of it all. Imagine a neural network as a simplified model of the human brain, with neurons connected by synapses. In a neural network, these neurons are nodes, and the synapses are the connections between them. Each connection has a weight, which adjusts as the network learns from data. The process of learning involves feeding data through layers of these nodes, adjusting the weights based on the error of the output compared to the expected result. Now onto transformers, which have revolutionized the field of AI, especially in natural language processing. The transformer architecture was introduced in a paper titled "Attention is All You Need" by Vaswani and his team in 2017. The core innovation here is the attention mechanism. Attention allows the model to focus on specific parts of the input when producing an output. Think of it like reading a book and being able to remember the plot by focusing on key events rather than every single word. Transformers use self-attention, which means each word in a sentence considers every other word to understand context. This is a game changer because it enables transformers to capture long-range dependencies in data, something previous models struggled with. A crucial part of making transformers work efficiently is quantization. Quantization is the process of reducing the precision of the numbers that represent your model's parameters. When we talk about precision, we usually mean the number of bits used to store each parameter. By reducing this, we can make models smaller and faster, which is critical for deploying AI on devices with limited resources, like smartphones. There are two main types of quantization: post-training quantization, where the model is trained with full precision and then compressed, and quantization-aware training, where the model is trained with quantization in mind from the start. Both methods have their pros and cons, but they share the goal of making AI more accessible and efficient. Let's take a closer look at how quantization impacts neural network performance. Imagine a model trained with 32-bit floating-point numbers. If you quantize it to use 8-bit integers instead, you drastically reduce the memory footprint and computational cost. However, the challenge lies in maintaining accuracy. Quantization can introduce errors because you're essentially rounding numbers, which can lead to precision loss. But with careful techniques, like choosing the right scale and zero point for each layer, you can minimize these errors and retain most of the model's performance. This brings us to the practical applications of combining transformers and quantization. One notable example is in voice assistants, like those on your smartphone or smart speaker. These devices need to recognize and process speech quickly and accurately, all while running on hardware that can't match the power of a data center. By using transformers for their ability to understand context and quantization to run efficiently on limited hardware, developers can create responsive and capable voice assistants. Another area where this combination shines is in machine translation. Translating languages requires understanding context and nuance, something transformers excel at. Quantization ensures that these models can run on a wide range of devices, from high-end servers to budget smartphones, making real-time translation more accessible and widespread. It's important to address some common misconceptions. One is that quantization always leads to significant accuracy loss. While it's true that some loss is inevitable, advances in quantization techniques have made it possible to achieve near-original accuracy levels. Another misconception is that transformers are only useful for language tasks. In reality, they're being used across a variety of domains, including image processing and even protein folding, because of their ability to model complex dependencies. So what's the takeaway here? The synergy between transformers and quantization is a powerful one. Transformers provide the ability to handle complex, context-rich data, while quantization ensures that these models can be deployed efficiently across a range of devices. This combination is not just a technical achievement, it's driving the democratization of AI, bringing sophisticated capabilities to more people and applications than ever before. As we continue to explore and innovate, the potential for these technologies is vast, promising to reshape industries and everyday life in ways we're just beginning to imagine.